exactly, moles times molar mass. So just check what is given, and then you have to see what you have to find and just rearrange the terms. Okay, if you have square, then you need to take care of this. Like you have kinetic energy formula, which is half mass times velocity square. If you have to find velocity here, that means you need to isolate velocity. Let's say you have given mass, which is 20 kilograms, and kinetic energy is suppose 10 joules. Can you work it out? Can you make velocity the subject of the formula?
So you want mass or which one?
You have to um,
Of
make find velocity. Find velocity. If
the
mass and
mass
energy is given.
was the mass 20
Yeah,
and the okay. So 20. What was the EK equal to? 10.
10. Yeah. Or you can just tell me general formula if this is just an example. I've taken random values.
Is 1.
Okay, yeah, 1. So basically what you did, because it is V square, right? So
Yeah.
square, can you tell me the general formula that you used? First, I want to ask from you if you are.
Um, 20 divided by 20. Then you root on the what's the question?
You have to make this is equation for kinetic energy, right?
Yeah.
Suppose you have to find velocity. So can you rearrange terms and tell me the equation?
Velocity is root 2 energy, not energy, EK divided by M.
Hmm. And then
Right, that's it. The root
yes, root will be for both of them or just one of them? For complete.
was above.
Yes. So this is whenever you have square and when you are moving it other side, it becomes square root. Suppose you have cube, so it will become cube root. Cube root means like if you have square a cube root of 8, that means you need to make a group of three same number, like 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8. So cube root of 8 is 2. Okay, so whatever is the exponent, that will go the other side and it will become cube root accordingly. Let's say, suppose you have like this, x to the power 4 is equals to let's say 16. Okay, and you have to find value of x. What you will do, if you take this other side, it will become this root, and this will you will write here 4. It means its value is, because you can write 2 times 2, if you multiply 2 4 times, this is 16, so x is 2. You need to make the group of whatever is outside square root, this root, this is 4, so you need 4 numbers, same numbers, to write it outside root. We will talk about this in detail in exponent, it's coming. So yeah, so this is just basically to find any variable you need to isolate it. Isolating means just take all other terms, that you have to move all other terms other side, and that's how you get whatever you need to find from the question. So um, what you need to keep in mind is when you are doing this type of you are trying to find one variable, you need to undo operations. Like here we had square, so it converted into square root because we are going in the backward direction. You have to keep balance. Whatever you are doing one side, you have to do it other side also. Okay. And also you need to take care of units and square root and square. You should know what is the opposite of squares, it's square root. What is the opposite of cube? You have to use cube root. Next is ratio. Ratio means for every part of one thing there are how many parts of another thing. Suppose if there is a solution which has 2 ratio 5 sugar to water, so it means for every 2 grams of sugar, there are 5 grams of water. So if for every 4 grams of sugar, how many grams of water would be there?
For every 2 grams, there should be 5 grams of water.
Yeah, so for every 4 grams of sugar, what will be the water?
10 grams.
Exactly. So this is ratio. Ratio means like this is fixed. For every 2, it's 5. So for every 4, it will be 10. For every 6, it will be 15, like that. Okay.
Yes.
So we can write ratio as fraction. We can write it as using this symbol of ratio. Like if we have 10 ratio 20, it is same as 1 half because we can simplify 10 by 20 as 1 half, right? If we have 2 ratio 4, that is also same thing, right? Are you getting?
Yeah.
Hmm. We can also scale it like we just did. Just I asked for 4 gram of sugar, how many grams of water is needed. So we scaled it up. Like if I have 1 ratio 3 and I want to suppose I'm making something, and for that recipe I'm using a ratio of 1. Let's say adding an ingredient A and B. Ratio of ingredient A and B is 1 ratio 3. This is for 2 people. If I have to make for 4s, I will multiply it by 2. So this will become 2 and this will become 6. So this is scaling up ratio. This is used in chemistry when you are balancing equation, right? Like
Yep.
you have any equation, let's take any equation. Let me take an example. This one is simple. Uh, okay. Balance. Let me go here. Yeah. So let's take this one. What's wrong? Hmm. No, I want a bit. Okay. Not this one is. Okay, we can take this one. Yeah. Okay. So let's say we have here C2H6O. It react with oxygen. It make water and carbon dioxide. You can see this is not balanced. How do we check if it is balanced or not? For each element, you have to see the number of atoms. Like here you have 2 carbon and this side you have 1 carbon, right? Here you have
Yeah.
6 hydrogen. This side you have 2. Here you have, so what you need to do, just write all the elements carbon, hydrogen, and oxygen. These three things are there, right? Then we will write reactant side and product side. This side is called reactant, and the result that we are getting is called product, right? So, number of atoms for carbon is 2. How many carbons are there in product side?
There's two, three.
It's 1, right? This is 1.
Oh, the oxygen.
Yeah, hydrogen reactant side.
6,
Yes, and product side?
2,
Good. Oxygen reactant side?
2.
2 and 1 here, right? 2 plus 1.
Yep.
So total 3, right?
Yes.
And product side?
3.
3. So oxygen is balanced. So if I need to balance carbon, what should I multiply this side? Because as you can see, this is 2, right? This is 1. What should I multiply 1 with to get 2? What do you think?
Uh, 2.
To make this is 1, right? To make them equal, we will do 2, yeah. And this side we have 6. We have 2 here. So what should I times it to get 6?
3.
3. Good. Now let's go product side. And where we have carbon here, right? Product side this. What should I write
Yeah.
in front of this?
2. No. So which
Yes,
one?
2, right? We just multiplied by 2, isn't it?
Yep.
Yeah. So we always, when we are balancing, we need to write in front of that. Because why? Because this CO2, this is the, when these tiny numbers, these are the part of formula. But when we write a number in front of that, this is not the part of formula. It explains that there are two molecules of carbon dioxide. Okay. Now
Yes.
what should I multiply hydrogen with on product side?
3.
3. So I will write here 3, okay? But if you notice here, if we did 2 times 2, there are 4 oxygen and then this is 3, so it is now 5. Let's check the other side. Here we have still 3, isn't it?
Yes.
Why? Because this 2 is with carbon as well as with oxygen, isn't it?
Mm-hmm.
So what should I do this side now? Let me erase this. How many oxygens are there product side now?
That was 5.
Okay,
No, no,
2, 4.
3. There's 7.
Exactly, there are 7. Um, Now, and right side, I mean, sorry, reactant side,
There's 3.
3. So what should I do? If I put here 3, let me do, this is 3. So see, 3 times 2 is 6. 6 plus 1 is 7, right? Now both side we have 7, 7, right? Did you get this?
Mm, 3 times O2. Yeah.
This is 6, but this one is there. Yeah. So basically here we are using the concept of ratio, because see how I scaled it up. Like this is 2, this is 6, so I multiplied it with 2 to get 2, right?
Yes.
Okay. I will give you a simple one. Let me see if you can do this. Mm, okay. Okay. So you have nitrogen, nitrogen react with hydrogen and it gives ammonia. So let's balance it. You try it?
Uh, N equals 2.
Yes, and it's 2 this side.
2.
This is reactant, this is product. Okay, this side we have 1 and then hydrogen.
H equals 2.
Hmm.
And the other side, H equals 3.
Yes.
So you times you put 2
Yeah,
in front of the
this one, right? Product side, right?
Yeah, that times the other product, the hydrogen, by two too, so that turns into six.
Okay, so I should write here 2.
Um, yeah,
But this makes here 4 hydrogen and here 6.
three. Put three in front of the H.
Yes, exactly. Now 6 and 6. See, why? Because 2 and 3, they don't have common factor, common multiple or factor, right? What
Yes.
you need to do whenever this is the case, multiply this number with this. Like here, we multiply by 3. Let me use a different color. This one we will multiply by 3 and this by 2. So they both become 6. Clear?
Yeah.
Okay. Now a very important topic which we were also using yesterday, gradient. Gradient is measure of how steep a line is on a graph. Let's say we have this graph, graph A and graph B. So this graph is like this and the other one is like this. So which one is more steep, A or B?
A.
Yes. So if A is telling us about speed, that means the speed is here, it is greater. The change in speed is greater as compared to B in case of A. Okay? Because
Yeah.
gradient is, tell us about the rate of change between two variables, which one variable is on x-axis, other is on y-axis. How y is changing with x, this is what it explains. If it is changing faster, if it is changing in a negative way, if it is increasing or decreasing, if it is not changing, then it is constant, then the change, the gradient will be 0 if there is no change. Okay, in that case the graph goes like this, constant graph, right? So
Yes.
the formula to find the change, how two variables are changing, how y axis is changing with x, is rise over run. Rise means change in vertical axis, y axis, and run means changes horizontal axis. So we have this graph. Let's say on x axis it is representing distance or displacement. On y we have time. Let's say this is 10, 20, then we have 30, 40, and 50, like this. And here we have 2, 4, 6, 8, and 10. Okay. And the
Yes.
graph is a straight line which is representing a uniform motion. So distance time graph gives us what? Any idea? Distance time graph gradient gives us what? Change in
Right.
distance. Sorry.
You get rise divided by run.
Yeah, rise divided by run. This is what you need to do. But my question is, what is change? Is the quantity when we talk about how much distance is covered in how much time? What is that quantity called?
Miles per hour.
Speed, right?
Well, yeah.
Velocity. Because its formula is distance over time or displacement over time. So,
Yeah.
um, let's say we have given a graph which is of distance time graph. We have to find velocity. Because now you are in higher, so they will not clearly mention that you have to find uh, you have the formula is this and all. You should know that gradient of distance time graph is velocity, because gradient means change in y axis. This is the symbol of change, this is called delta. Change in y axis over change in x axis. What do we have here on y axis?
The distance.
Distance. And on x axis we have
Time.
time. So change in distance over time, change in time is called speed or velocity. Now if we, let's say how, let's see how do we calculate it. We need 2 points to find rise over run, because to find change, the formula, whenever you have to find change and you have 2 points, you need to do final minus initial point. Okay,
Yes.
let's say we take this point 40 and this is 8. Let's say this is 8, and we say we take this point which is 4. Okay,
Yes.
so at this point, let's say this is point B and this is point A, we are calculating what is the change in, what is the speed between A and B, this point. So at point B, what is the distance at point B?
20.
Point B.
No. 40.
Yes, 40. So, and the formula is this actually, y2 minus y1 over x2 minus x1. Y2 is the coordinates on y-axis, and y1 is also a coordinate of y-axis. X2 and x1 are the coordinates of x-axis, which is corresponding to the same point. Now y1 is, this is y2 and y1 is
So,
20, right?
yep.
X2 minus x1 is,
20.
you now you have to look on the x-axis.
Oh, 8 minus 4 is 4.
Yes. So this is 20 over 4, which is 5 meters per second if the unit is meter and this is second. Okay.
Yes.
So this is called gradient. The formula is change over y-axis. How do we find change? Final value minus initial value. Take the corresponding value of x-axis and then we do it. Um, Let me take a graph and give it to you. I think I can take from here, just 1 minute. Any graph. Distance. Okay, not this one. Let's take a simple one first. Okay, I'm just gonna take this one. Hmm. Let's see this graph. Okay, now this is distance time graph. You have to find velocity. So take any 2 point, like you can take one this point, you can take any 2 point if it is not mentioned that you have to find between this and this. Why I'm taking this point? Because at this point we have 1 and 50 clearly, right?
Yeah.
Suppose, yeah, and other point you can take this or any other point. Let's say you take this. Okay, so can you tell
Yeah.
me velocity?
The velocity. What's the equation for velocity?
Y2 minus y1 over x2 minus x1. I mean, this is the formula for gradient which you have to use.
So 100 minus 50 is 50.
Yes, divided by,
And then divided by 2 minus 1.
yes, absolutely correct. So the answer is just 50 by 1, which is 50 meters, kilometers per hour, right? Because this is
Yes.
kilometer, this is hours. So, did you get it? How to use the gradient concept?
Yes.
Yeah, just you can take any 2 points. You can take this and this. This will give you same answer. So in this graph, let's see this graph. Look at this graph. So from A to B, the graph is going in the upward direction, right? It's going in the upward direction, right?
Yes.
So is velocity increasing or decreasing?
When it goes up, velocity is increase.
Increasing. If it is going in the upward direction, that means it is increasing, okay?
Yes.
B to C. B to C. Is the velocity changing?
No.
So there is no change. So velocity is zero, right?
Yes.
C to D graph is going downward. So velocity increasing or decreasing?
Decreasing.
Good. D to E, this part, velocity,
Staying.
yes, zero. Okay, distance is same, so zero. E to F again decreasing, right? Because can you explain why it is decreasing E to F?
Because it's going down. The distance from the house is decreasing.
Yeah, because the graph is going in the downward direction. Okay, great. Let's go back to this and yeah, here. So whenever you have to find gradient, you just need to take any two coordinates which are passing through which the line is passing, just subtract the y coordinate and divide it with the x coordinates difference. Okay, suppose you have given 0 0 and 2 4. So this is x1, this is y1, right? This is x2
Yeah.
and this is y2. You know about coordinates, do you?
Somewhat. Actually,
Okay.
yeah, I'm pretty good at it.
Okay, but you know that this is x, this is y, right?
Yeah.
So the formula for gradient is, can you tell me what is the formula?
Zero. No. Zero.
Formula is y2 minus y1 over x2 minus x1.
Is that a 4 on the y2?
Yeah, that's 4.
4 minus 0 is 4, and then 2 minus 0 is 2, so 4 over 2,
Yes,
which
which
is
is
what?
exactly. So gradient is 2. Yeah, like here. Okay, can you find gradient for if you have given these 2 points?
Uh, Gradient equals speed. 0, so 10 minus 0 is 10, and then the other one's 50 minus 0, so 50.
So the answer is
50 over 10, or is it the other way around?
yes, which is just 5 meters per second. Okay.
Yeah.
Okay. Have you learned about acceleration?
Mm,
What is the
Accelerate.
formula? Hmm.
Is it the same as the other ones?
Acceleration
Or
is change in velocity. Velocity is change in distance with time. So acceleration is velocity divided by time. Change in velocity with change in time.
yeah,
So if you have given a graph with velocity and time, and if you find its gradient, because gradient formula is y axis, whatever is on y axis, divide that with whatever is on x axis, and v over 2 is what? Acceleration. That's why whenever you have velocity time graph, its slope, its gradient give you acceleration. If you have distance time graph, its gradient gives you, for
it's 20
distance,
divided by 4.
no, I'm asking if you have a distance time graph, gradient of distance time graph gives you what?
Distance. is x1. No,
See,
x2 minus x1 divided by y2 minus y2 my y1.
y2 minus y1 divided by x2 minus x1. Okay. We can also use it in chemistry reaction rate graph, like what is the rate of reaction, how fast the reaction is going, or if it is going slow or fast. So if you have given 2 points, you can just find by using the gradient formula. So always you have to check the units, like if you have distance time graph and distance is given in meters and time is given in seconds, so the speed unit will be meters per second. But what if distance is given in kilometers and time is given in hours? Then the answer, whatever you get, you will write the answer in kilometers per hour. Okay.
Yes.
Next is if you get a steeper line, like if you have two graphs, this is number 1 and this is 2. So 1 is steeper than 2, right? So which one will be having large gradient, 1 or 2?
One.
Yes, steeper line, large gradient. Flat line means no change, so its gradient is 0. Like if you have speed, this is distance, this is time, and graph is going like this, that means speed is
0.
0. Negative means the value is decreasing, going downward. Graph goes like this. Is this clear gradient? A little bit maybe. Because it's a very
Yeah.
vast topic, but I just told you according to what you have to use in science math. Um, and because also the exams are very close, so otherwise I will, when we will do math in detail, we can do this topic. But I think now you have an idea, right?
Yes.
Hmm. Now when we are doing calculation and you have multiple operations, always use order of operation. For order of operation, use this bid mass. B stands for bracket, I for indices, which include power, exponent, roots, D for division, M for multiplication, A for addition, and S for subtraction. We always go left to right. Like if we have bracket, we have to solve that first. Okay.
Yes.
Let's say we have this question here. So what we are going to solve first?
Brackets.
Yeah, we will solve bracket first. So yeah, can you tell me how much is this?
X squared minus 4, so 3 times 3 is 9, minus 12 is 5.
Yes, this is 5. So now we got 5 plus 2 times 5. After solving this, we got 5. So after this, in bit mass, after bracket, now we have addition and multiplication. So in what will you perform first out of these two, addition and multiplication?
Multiplication.
Yes. So now multiply them.
2 times 5 is 10,
Yes. After that, you will
plus
just,
5.
yeah, 15, right? Also, if you have, this is very important, division and multiplication, they are equal priority. So you can do any of them first. Same for addition and subtraction, okay? Like if you have 2 plus 5 minus 10, you can first add them, or you can do like this. Both ways are correct, okay? Because they have same equal priority. Brackets can change the order, so you need to see carefully. Now let's talk about exponents. Let's see, we have time, okay. So exponents are also called power or indices. So they are a way of writing repeated multiplication. Suppose if I have 2 to the power, like I'm, rather than writing 2 4 times, I can just write 2 to the power 4. So this explains what I'm multiplying, and power explains how many times I'm multiplying it. Like here we are multiplying it 4 times, so the power is 4, which is 16, right?
Yes.
There are some rules when we are dealing with exponents. Have you learned about these rules?
Um, what the powers add together?
Yeah, about the exponent rules, power rules.
Yeah.
Okay. So whenever first rule is when two exponents are in multiplication and base is same, like you can see here 2 to the power 3 times 2 to the power 4, they are in multiplication and base for both of them is 2, so just add the power. So this will become 2 to the power 4 plus 3, which is 7. Okay, this is
Yes.
first, just add power when they are in multiplication having same base. Division, same thing, if you have same base and they are in division, just subtract power. Like here 5 5, so power is 6 minus 2, so you will get 5 to the power 4 if you subtract them, right?
Yes.
Now if you have two power, you need to just multiply them and write it once. For example, here 3 to the power 2, then we have parenthesis whole to the power 4, so just multiply them. 2 times 4 is 8, so the answer is 3 to the power 8.
Yep.
Next is zero exponent. Zero exponent means anything to the power 0 is 1. Yeah. 7 to the power 0 is 1, 1 million to the power 0 is 1, 1000 to the power 0 is 1, anything. Negative 1 to the power 0 is 1. But a cannot be 0. 0 to the power 0 is not defined. Okay.
Yep.
Negative exponent. When you have negative exponent, you can convert it into positive by putting 1 in the numerator. Let's say you have 2 to the power negative 3. You can convert this negative 3 into positive if you write 1 in numerator. 1 over 2 to the power positive 3. Let's say you have 8 to the power negative 4. You can write it as 1 over 8 to the power positive 4. Okay. This is called negative exponent. Did you get it?
Not really.
Oh, let me explain again. Negative exponent means the power, if the power is negative, you can convert it into positive by writing 1 in the numerator. Like here 2 to the power negative 3. This is negative exponent. If you write 1 in
Yeah.
the numerator and this into the denominator, this power become positive. Let's say you have 5 to the power negative 2. You can write it as 1 over 5 square. They both are same thing. Just this negative is gone. Right here we have positive 2. Okay.
Yeah.
Did you get it?
Yeah.
Can you tell me 6 to the power negative 3 into positive power, convert it into positive power?
1/6 to the power 3.
Exactly. This is called negative exponent. Then fractional exponent is whenever you have a number inside root, and if you have, let's say, let me write a number only. Let's say you have 16 and outside root you have 4. So you can write it as 16 to the power 1/4. This 4 will become in, this will come in the denominator. Okay. Like you have square root of 9, so square root means you have tiny 2. Here you can write it as 9 to the power 1/2. So whatever is here, this goes into the denominator. Let's say you have 27 to the power 3, 27 cube root. Can you tell me how you will write it?
27 to the power 3.
1/3, right? Because you have square root, I mean cube root. Let me tell you what I'm doing here. See, whatever is outside root, this tiny number, suppose you have 7 and you have 526. You can write it
Yep.
as 526 to the power 1/7. They are same thing.
Mm.
So if you have 7 here and if you remove the root, this will become 1/7. into the exponent. 26,
Okay.
and here you have, let's say, 5. Can you tell me this one?
26 with the power of 1 to 5.
Exactly. Great. So when you are applying these rules, you have to make sure the base is same, especially in multiplication and division one here. And
Yep.
negative exponent flips the fraction. And fractional exponents means roots, like we just did this root.
Yeah.
Hmm. Now, next topic is scientific notation. Have you learned about scientific notation in science? This is a topic
Uh,
of science also.
oh, yeah, yeah. I learned it in
Okay,
maths.
okay. So we use it for when we are writing a very large or very small numbers using the power of 10,
Yeah.
especially in physics, chemistry. Suppose we have to write atomic size, which is very small. So instead of writing 9 zeros, we can write 10 to the power. I mean, instead of putting after decimal 9 zeros and then 1, we can write 1 times 10 to the power negative 9. Negative 9 means, I'll just explain here. But this makes it easier to write, and to avoid confusion, we use this. Or for speed of light, which is very fast, we use scientific notation, like that is 3 times 10 to the power 8 meters per second. So instead of writing 3 and putting 8 zeros, what we do, we write 10 to the power 8. So scientific notation is, we write a coefficient here. This should be between 1 and 10. It should not be greater than 10 or smaller than 1. And then other numbers we write in 10 to the power, because there are lots of zeros. So we write it as an exponent. Let's take an example to understand. So here this is speed of light, okay? In 1 second it travel this much meter, which is
Yep.
300 million thousand, okay, 300 million. What we can do it, we can write it as, we count, can you count number of zeros here?
There's 8.
Yes, so just write first non-zero number, write 10 to the power, how many zeros are there? 8, so 8. Okay,
Yep.
this is scientific notation. Like Avogadro's number is this big, so instead of adding 23 zeros, what we can do, actually this is 21, 22, 21 zeros. There are 21 zeros. So what we can do, we can write it in scientific notation. How? In scientific notation, the first term has to be greater less than 10. As you can see, non-zero number is 602. So 602 times 10 to the power, how many zeros are there? 3, 6, 9,
3, 9.
12, 15, 18, and 21. There are 21, okay? Now, because in scientific notation, the first number, this 602, this should not be greater than 10. So to convert it into a number which is less than 10, we can put a decimal here, right?
Yep. 6.2 times.
6.02 times. Now I have put the decimal after 2 digit, so I will increase it by 2. I will add 2 here. So this will become 23. Okay, because I put here decimal after 2, so you need to add here 2 to make a balance, because I am reducing this number. I cannot do anything by my own, right?
Yep.
So if I'm reducing this, I will increase this by the same amount, which will make a balance, and the answer will remain same. This is the point. Let's see.
Mm.
So for large number, just count the number of zeros, put it into the 10 to the power something. Suppose, let me just give you this one. Can you write it in scientific notation?
4 times 10 to the power of 5.
Exactly. 1 minute. What about this?
That is 4 times 10 to the power 6. No,
9.
9 times 10 to the power
Yeah.
6.
Okay, good. What if I have, let me just, where's this? Let's say I have 206 and then I will put 5 zeros, maybe 6. Can you try this one?
Yep.
Yeah, tell me.
9 times, oh, 200 and, is it 1, 2, 3, 4, 5, 6? So, the 2.06
Hmm.
times 10 to the power of 8.
Very good. Absolutely correct. You got it. Okay, so this was about large numbers. You can see all of them are really large number. But what about small numbers? Like you can see 0.000. This is small, right? If a number. Uh,
Yes.
so how do we do for small numbers? Start with the decimal point, move it 1, 2, 3, 4 until this number, because we cannot write 56, we need a number less than 10. Let's write it as 5.6. How many steps we moved? 1, 2, 3, 4. So write 10 raised to power negative 4. Why negative? Because it is a small number. So negative
Yes.
power means it is a small number. Just count the number of steps we are moving decimal, write that into negative powers. Let's start this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? Because after 5, so this will become 5.0 and 10 to the power negative 11 because they are 11 steps, right?
Yep.
Let's do this one. 0.000000112. Can you try this?
It's, does the first one count before the decimal?
No, no. Just from start from the decimal.
1, 2, 3, 4, 5, 6, 7. Yeah, it should be 7.
1, 2, 3, 5, 6, 7.
Yeah,
Okay.
is it 1,
1 point.
12 times
Yes. Times
1.9
10 to the power.
minus 7?
Yes, you got it. Great. Okay. Now, let me give you one more. Right here. Let's say we have 0.0000215. You have to count the number of steps, okay, which you are moving, like this one, this two, okay, not zeros in this case. Let me, yeah.
Uh, 1, 2, 3, 4, 5. So 2.15 times 10 to the power negative 5.
Okay, just let me check it. 1, 2, 3, 4, 5. Yes, 2.15 into 10 to the power negative 5. Okay, that's great. Yeah, I think this is what we were supposed to do. Can you summarize what we did today?
Focused on powers, like times 10. I don't know the name for it specifically, but you times 10 to the powers, and then did the distance